How's it going, everyone? This video is going to go over some examples of probability questions using a probability tree. And this is the situation we'll use. So let's say in some city, the probability that a random person wears a seatbelt, and we'll use a B to represent that condition, the probability of that is 0.95. And the probability that they get injured after a serious accident, given that they're wearing a seatbelt, is 0.1 or 10%. The probability that they get injured in a serious accident, given that they're not wearing a seatbelt, is 65% or 0.65. So first thing we'll do, we'll populate our probability tree. Okay, so there's our tree right here. Okay, so initially we have two possibilities, right? Someone wears a seatbelt or they don't. And whichever path they go on here, then there's another two possibilities. They get injured or they don't, right? After a serious accident, right? Same with if they don't wear a seatbelt. Either they get injured or they don't. So we're going to populate every branch of this tree here with the probability of going down that particular branch from the previous node. So some information we're given. Okay, the probability of wearing a seatbelt, we know that's 0.95. Right, so that's the probability of that right there. Okay, so then the probability of not wearing a seatbelt must be 0.05. Okay, or 5%. Right, and that's based on the concept that the probability of an event not happening, that's just 1 minus the probability of that event happening. Right, because it's either going to happen or not happen. Right, so the two probabilities together have to add up to 1. And the probability of them getting injured after a serious accident, given that they are wearing a seatbelt, we're given that, that's 0.1 or 10%. And based on this same principle right here, it means that the chances of them not getting injured wearing a seatbelt, given that they're wearing a seatbelt after a serious accident, is going to be 0.9. Okay, we're also given the probability of them getting injured if they're not wearing a seatbelt, right, after a serious accident, that's 0.65. And so again, the probability of them not getting injured after a serious accident, given that they're not wearing a seatbelt, will be 1 minus that, which will give us 0.35. And here I'm just going to say injured or not injured, with the understanding that I mean injured or not injured after a serious accident. Okay, so then we can calculate some more probabilities here. So for example, what if we want to know, well, what's the probability that they're wearing a seatbelt and they get injured? Okay, let's say we want to know something like that. Well, so in general, right, the probability of an event and some other event, right, that's the probability of event A. Let's say we have events A and B. It's the probability of event A multiplied by the probability of event B, given that event A already happened. Okay, well, why is that the case? Well, let's break this down, right, using the definition of probability. The probability of A is the number of ways A can happen divided by the total number of possible outcomes. And the probability of B given A, right? Well, that's the number of ways that A and B happen together divided by the total number of outcomes corresponding to A, right? That's what conditional probability is. We're only looking at those instances of B that happen together with A, and the total number of outcomes we're considering possible is the total number of outcomes where A happens, right? Because we're saying given that A occurred, right? Given that A occurred, it means that the only possibilities are the ones where A happened. And it means the only possibilities of B are the ones where A happened together with B, okay? So what happens then is we see that we have NA and NA cancel out, and we just have the number of ways A and B occurs divided by the total number of possible outcomes, which is the classic probability definition of the probability of some event. In this case, that event is A and B. It's the number of ways that event happens divided by the total number of possible outcomes, right? So that's a demonstration of why this formula is in fact true. So now we can use it. Okay, so in our situation right here, the probability of B and I, okay, well that's just the probability of B multiplied by the probability of I given that B occurred. Okay, so the probability that B happened, right, 0.95, right, that's right there. And the probability of I given that B occurred is 0.1 right there. Right? And that equals 0.095. Okay? So the probability that a randomly selected person was wearing a seatbelt and got an injury after a serious accident is 0.095 or 9.5%. So if you notice, to calculate that probability, that's the probability of ending up right here. Okay, it's the probability of ending up right here on this tree. And we just had to multiply the values as we go from the base of the tree up until the end of that branch there. We just had to go 0.95 times 0.1. And that's the case with all of our questions about the probability of something and something else. Okay, so for example, let's say we want to know, okay, well, what's the probability that someone's wearing a seatbelt and doesn't get injured? Okay, well, that's going to be the probability of wearing a seatbelt multiplied by the probability of not getting injured given that you're wearing a seatbelt, right? So that's going to be, again, 0.95, the probability of wearing a seatbelt, times 0.9. Okay, the probability of not getting injured given that you're wearing a seatbelt. So again, we're just multiplying by the values corresponding to each branch as we go from the start of the tree to the node that we're interested in, right? So 0.95 times 0.9. Okay, and that gives us 0.855. Right? Okay, let's say we want to know the probability of not wearing a seatbelt and getting that injury. All right, so again, we just go down that branch, not wearing a seatbelt and getting an injury, and we just multiply by the probability associated with each branch. So it's going to be 0.05 times 0.65. 0.05 times 0.65, and that gives us 0.0325. And if we want to know the probability of not wearing a seatbelt and not getting a serious injury, injury after a serious accident, okay, well then we're just going down this path right here, right? So 0.05 times 0.35. .05 times 0.35. Okay, and that gives us 0.0175. There's a common misunderstanding that people make when they're looking at conditional probabilities. They might see something like this and they say, oh, the probability of getting injured if you're not wearing a seatbelt, it's only 0.035. It's 3.25%. That's a pretty small percent. So I guess seatbelts aren't that important. That's actually a misunderstanding because this probability here takes into consideration all the people, including the 95% of people who are wearing a seatbelt, right? So because there's so many people wearing seatbelts, the chances of you randomly selecting someone not wearing a seatbelt is really small. In fact, it's 0.05. That's how small it is. And then those who got injured is a fraction of that small fraction, 0.65, which is what results in this number, 0.0325, that you get. But it's wrong to interpret that as saying that, oh, so seatbelts aren't so important. What the number is that you should be looking at to determine how important seatbelts are is this number right here. Given that someone's not wearing a seatbelt, the chances of that injury is 65%. Given that they're not wearing a seatbelt, the chances of that injury is only 10%, which of course is a huge difference, right? So this low probability here and this low probability here, right? One of the reasons they're low is because they're taking that 0.05 and multiplying by it, because you're so unlikely to find someone not wearing a seatbelt. So let's calculate. Let's do two more questions. Okay, let's look at the probability that someone was not wearing a seatbelt, given that they did receive a serious injury. Okay, so from the probability tree, this is a little bit more difficult to see, right? So let me clear up some space here so it's easier to look at. Okay, so we want the probability that someone was not wearing a seatbelt given that they received a serious injury. So all these numbers right here that we just calculated, okay? So belt and injury, belt and not injury, no belt and injury, no belt and not injury, right? So these four numbers here, that's all the possibilities that could happen, right? Those are all the possible end results, right? They'll cover all the bases. And if you notice, they'll all actually add up to 1. So we're looking at, okay, given that an injury occurred, of all those possibilities, what are the chances, or what portion of those are ones where a seatbelt was not worn? Okay, well, let's look at that portion of outcomes where an injury occurred. All right, so we have 0.095, right? This one here, right? That's the belt and injury. And then we have the 0.0325. That's the no belt and injury. Okay, and of those, which correspond to a seatbelt being worn? This one right here. Okay, so it's going to be this out of the total portion that corresponds to an injury occurring. Okay, so we're going to have that 0.095 divided by 0.095, which is injury with belt, plus 0.0325, which is injury with no belt. Okay, so what we get is 0.095 divided by 0.1275. That 1275 is the portion of all outcomes where a injury occurred. Right? So if you randomly select someone, what are the chances you've selected someone who received an injury after a serious accident? Well, it was 0.1275 is the probability of that, or 12.75% of the population. Okay, and what portion of them of the total was wearing a belt and received an injury? Right. That's 0.095. Okay, so what we get as a result is 0.745 approximately. 0.745 or 74.5%, which is a pretty huge number, right? So in this imaginary city we came up with here, okay, given that someone received an injury after a serious accident, the probability that they were not wearing a seatbelt, 0.745 or 74.5%. Okay. Alternatively, we can ask, okay, what's the probability that someone was wearing a seatbelt given that they did not receive an injury after a serious accident? Okay, so now of all of our 4 possible outcomes here, 4 possible results, which ones are we looking at, right? So it's given that they didn't receive an injury, right? So there's this one here. That's some of the portion of people who didn't receive an injury. And then there's this right here, another portion of people who didn't receive an injury. Okay, so the total portion that did not receive an injury is 0.855 and 0.0175. .0175. And then we have 0.855 there. Now of those two, which one corresponds to the portion of those who were wearing a seatbelt and did not receive an injury? Okay, and that's this one right here. Okay, they were wearing a seatbelt and did not receive an injury. And that's what we want, right? What's the probability that someone was wearing a seatbelt given that they did not receive a serious injury after a serious accident? Okay, so 0.855 was that number, right here. And then we calculate this. And what we get as a result is 0.9799. Okay, if we go to 2 decimal places, okay, 0.98 or 98%. Okay, so given that someone received an injury after a serious accident, the probability that they were not wearing a seatbelt is 0.98 or 98%. And so those are some examples using a probability tree. So I hope that helps, and I'll see you next time.